Alright guys, today we're going to look at how to determine the number of electrons, protons, and neutrons in pretty much anything. Okay? Some important facts about subatomic particles: the number of electrons determine the charge, the protons are going to tell you what element it is, the protons and neutrons make up the mass of the atom, um, and that's pretty much all you need to know for what we're looking at today. Okay? So, the atomic number is found on the periodic table. It's usually at the top or the bottom. It's going to be a whole number, right? And it tells you the number of protons. That's by definition the atomic number, the number of protons in the atom. Okay? If the atom is neutral, okay, and by definition the atom is neutral, okay, the number of protons is going to equal the number of electrons. So a lot of times if we're looking for electrons, if we can figure out the number of protons, we have it. Okay? Then we have what's called the mass number. Now, the mass number is not on the periodic table. That has to be given to you, or they have to give you the neutrons, and then you can calculate the mass number from the protons. Okay? Now, some people, they say, well, let's just use its atomic mass down here, the average atomic mass, which is the decimal number on the periodic table, and they round that up or down or whatever and say that's your mass number. Well, you can't always do that. Okay? And it's technically incorrect to do it that way because mass numbers tell you what isotope it is, and the isotopes are the ones that have different number of neutrons. Okay. If we look at the atomic symbol and where certain things are going to be at, uh, you have your element symbol here. If it has a charge, it'll be in the upper right, plus or minus. The mass number is going to be in the left on the top. The big number is always on top. And then your atomic number, the number of protons, is going to be on the bottom. Now remember, your mass number is the protons and the neutrons added together. Okay? So some good rules of thumb. The number of protons is always equal to the atomic number that's on the periodic table. So if you know the element, you can figure out the protons by looking at the periodic table. If we're looking at a neutral atom, then you also have the number of electrons. It's going to be the same as the number of protons. If we don't have a neutral atom, then the number of electrons is equal to the number of protons minus the charge. Watch out for negative charges because a minus, when you subtract a minus or a negative number, right, it makes it positive, and then you end up adding it. Okay. The other way you could figure out the number of electrons is by reasoning it out. You look at the charge, you say, okay, who's winning? Are the positives winning? Okay, which would be the protons, or the negatives winning, which would be the electrons, and by how much? Okay, so if you had a +2 charge, that tells us that the protons are winning by 2, so that you have 2 fewer electrons. Because remember, you change the number of electrons to change the charge. If you change the protons, it changes the element. If you need to figure out the charge, you just take the protons minus the electrons, or you reason it out. Okay. The number of neutrons is basically the mass number minus the atomic number. So in order to be given the mass number, it's more likely going to be written in some sort of isotope notation, either hyphen notation or nuclear notation or isotopic notation, sometimes it is called. Okay. And so hyphen notation looks like this. You have the name of the element dash the mass number. Okay, so carbon 12, that isotope of carbon has 12 protons and neutrons. Okay, not 12 of each, but 12 total. And oxygen 18 has 18 protons and neutrons altogether. Okay, the other way of showing isotopes is what's called nuclear notation or isotopic notation. This is where you have the element symbol, and then you have the atomic, or my bad, the mass number on top and the atomic number at the bottom. Okay, so here, this carbon 14, that's in hyphen notation right here, and then this nuclear notation, we have the mass number and the atomic number. All right, so now let's look at some examples of how to figure out the number of protons and electrons. The only time we can figure out neutrons is if they give us the mass number. Okay? So if you look at calcium, all we got to do is look at the periodic table, find calcium, Okay, calcium's right here, right? Here's the atomic number right there. If you're not sure which one's the atomic number, a lot of times the periodic table will have a little key on it, and it'll point to the different numbers and stuff and tell you what they are. So the atomic number by definition is the number of protons. So we know that calcium has 20 protons. Let me change to a better color. 20 protons. Okay? Now, because this is neutral, there's no charge right there. The charge would be in the upper right, it'd be plus or minus. There's no charge. Then we know that it also has 20 electrons. Okay? Let's look at another example. If we have an ion, now an ion is just a charged atom. So this magnesium has lost or gained some electrons, and it now has a charge. Well, for the protons, we just look at the periodic table. We find magnesium, okay, on the periodic table, and it's right there, and it has a atomic number of 12, right there where that little green thing just flashed up. So that tells us it's going to have 12 protons. So it has 12 protons, but it has a charge, okay? So remember, the number of electrons is equal to the protons minus the charge, okay? So it's going to be 12 minus a positive 2, okay? So it's just going to be minus 2, so that means it has 10 electrons. The other way we can figure it out is just by reasoning it out. Who's winning, the protons or the electrons? Kind of think of it like it's a game, okay? So the score is a positive 2, so that means the protons are winning. How many are they winning by? Well, they're winning by 2, so that means you've got to have 2 more protons than you do electrons, okay? So we already figured out the number of protons, so that means that we have 10 electrons, okay? Let's look at a negative ion, fluoride. The ion of fluorine, okay? So we look fluorine up on the periodic table. That'll give us the number of protons. Oops, wrong button. So we look fluorine, and it has an atomic number of, there's an atomic number of 9. Okay, so it's going to have 9 protons. Okay, and the electrons are winning. They're winning by 1. So we've got to have 1 more electron than protons. So 10 electrons. We can also do the number of protons minus the charge. Okay, so it's going to be minus a negative 1. Okay, so anytime you subtract the negative number, it makes it positive. So it's going to be 9 plus 1, which is 10. So 10 electrons. Let's look at another negative one, phosphide. It's the ion of phosphorus. So we find phosphorus on the periodic table. So phosphorus is right here. It has an atomic number of 15. Find my program. There we go. So it has an atomic number of 15, so therefore it has 15 protons. Okay? It's not neutral, so it's not going to have the same number of electrons. It has a negative 3 charge, so 15 minus a negative 3, right? That makes it positive, so we are adding 3 to that, so we have 18 electrons. Okay, also we can reason it out by looking at the fact that the charge is negative, so we know the electrons are winning, so that means we're going to have more electrons than protons. So how many are we going to have? We're going to have 3 more. Okay, here we have an isotope. Now we can actually figure out the number of neutrons. So there's no charge on this one, so once we figure out the number of protons, that's also going to give us the number of electrons. So here's carbon on the periodic table, has 6 protons, atomic number 6. Okay, so it's going to have 6 protons. If you hadn't figured out, the P plus is the symbol for protons. The 6 electrons, E minus the symbol for electrons. And then to get the number of neutrons, the neutrons is equal to the mass number, which is A, minus the atomic number, which is Z. Okay? So the atomic number, remember, is the number of protons. So 14 minus 6 is equal to 8. So we're going to have 8 neutrons in carbon 14. Okay? Look at another example, another isotope and hyphen notation. Remember, it's the hyphen notation is the element hyphen the mass number. Okay? So we know that it has a total of 22 protons and neutrons together. To find the protons, we look it up on the periodic table. Neons over here has 10 protons. Okay, so 10 protons. All right. It doesn't have a charge, so it's going to have 10 electrons. Okay. So to find the number of neutrons, we take the mass number, which is 22, minus the atomic number, which is 10. 22 minus 10 is equal to 12. So it's going to have 12 neutrons. All right, another example. This one, we're going to look at some nuclear notation. So again, remember for nuclear notation, the mass number is on top. The big number is always on top. The little number, the atomic number, is on the bottom over on the left side. So if we look at this one right here, we don't have to look this one up. It tells us the atomic number right there, so it has 92 protons, 92 electrons, because there's no charge. If there was a charge, it would be over here on the right, in the upper superscripted. Okay, so to find the number of neutrons, it's already set up for you. You just take the mass number minus the atomic number, so just take that 239 minus 92. Okay, we get a 7, then that's going to be a 4, so we get 147, so 147 neutrons. All right, let's look at another example. This is iodine 124. Okay, so again, they give us the atomic number right there, so it has 53 protons, 53 electrons. Okay, so we just subtract that 53 from the 124. We get a 1 right there. Then that's basically 12 minus 5. We get 71 neutrons. Okay? All right, and that's how you determine the number of protons, neutrons, and electrons.